All right, this is video part 2. All right, we are doing example 5. Last example, then we're going to go back and do one partial section in chapter 10 to cover Pythagorean theorem really quick, and then that will be it. So if we have x to the 2/3 minus 5x to the 1/3 plus 6 equals 0. Okay, so again, this might not look quadratic at first glance, but you can solve it quadratically. So the first thing we want to do is we want to get our variables the same. So we have x to the 2/3 and x to the 1/3, and those aren't actually the same, but we can recognize that this is actually x to the 1/3 squared, right? Because when we square a exponent, we're just multiplying. So if you multiplied this, you would end back up with x to the 2/3. All right, so minus 5x to the 1/3 plus 6 equals 0. So now we're going to use the exact same concept we did in the last example. So we're going to take our x to the 1/3 here and here, and we're going to replace it with a different variable. So let's, here in the book they replaced it with m. We'll do that. All right, so here we have m squared. M is going in place of x to the 1/3 minus 5m plus 6 equals 0, where x to the 1/3 equals m. So now let's just solve it quadratically. So let's factor it. Okay, bring your m down. And we're going to have 3 and 2. So we're going to, this is positive and this is negative, which means both of these are negative. So now we have m minus 3 equals 0, which means that m equals 3. And here we have m minus 2 equals 0, which means that m equals 2. So let's go and plug x to the 1/3 back in for m. So what we have now is 3 equals x to the 1/3, and 2 equals x to the 1/3. So how do you solve that? Okay, so this is just like saying, let me come down here. This is like saying 3 to the 3rd or 2 to the 3rd. So what do we have here? We have 3 times 3 times 3, 27 or 8. So your solution set is going to be 27 and 8. All right, press pause and try practice 5, please. All right, for practice 5, you should have gotten for your solution set 1 and 64. Okay, so now please turn back in your book. Let me see. Here we go. It's page 637, and we're going to briefly cover Pythagorean theorem. Most problems you will see using Pythagorean theorem are word problems. So we're just going to do a couple, and then we're going to call it the end. Okay, so we all know, for example, Pythagorean theorem always deals with right triangles. We know that the side across from your right angle is your hypotenuse, and that these are the legs here. Legs of the triangle, hypotenuse of the triangle. Your legs are labeled with A and B. Your hypotenuse is always labeled with C. And the Pythagorean theorem says that A squared plus B squared is C squared. Okay, so if we have a problem that says, here's our right triangle, that says this side is 4 and this side is 10, and we don't know what that is. So label so that we don't get confused. We know this is always our C across from the right angle is always our C. So we have 4 squared plus x squared equals 10 squared. So we have 16 plus x squared equals 100. Okay, so we have x squared equals 84. To get rid of your squared, we're going to square root both sides. So you have x equals the square root of 84. Can that be broken up? Any. Can it be simplified? So when you're simplifying square roots, you always want to go with your perfect squares. So we'll start with 4. Does 4 go into this? It does, 21 times. So that can be simplified as the square root of 4 times the square root of 21. We know what the square root of 4 is. It's 2. So we have x equals 2 times the square root of 21. And there's your answer. So let's try, press pause and try practice 6. And then we'll go on with using a word problem example. I think there's just one, and then we'll be finished. All right, for practice 6, for your answer, you should have come up with 6 times the square root of 3. All right, so let's do this word problem here on the bottom of page 637. It says a 50-foot supporting wire is to be attached to a 75-foot antenna because of surrounding buildings, sidewalks, and roadways. The wire must be anchored exactly 20 feet from the base of the antenna. So if they don't provide a picture, draw one yourself. It says a 50-foot supporting wire. So it's a wire that's 50 feet, and it's supporting this 75-foot antenna. It's in this there. All right, 75-foot antenna. Let me redraw this a little bit better. There we go. So this whole thing is 75 feet. And it has to be anchored 20 feet from the base. So if it's anchored 20 feet from the base, here's the anchor spot right there. And we know that the ground and the antenna are going to be parallel, giving us a right triangle right there. It says that local regulations require that the supporting wire be attached at a height no less than 3/5. So this height right here has to be 3/5 or greater of this whole thing of 75. And it says, have the local regulations been met? How high from the base of the antenna is the wire attached? So what is this distance here? We don't know. We need to know that. This whole thing is 75 feet. So to find that missing length, we need to figure out what this length is and then subtract it from 75. So to set this up, since this is 50, we would say 20 squared plus, we don't know this is our b, plus b squared equals, this is our hypotenuse here, across from the right angle, 50 squared. Okay? Well, 20 times 20, 400, plus b squared equals, and what's 50 squared? 2,500. All right, so just subtract 400. So we have b squared equals 2100. Now you can square root both sides. So b equals the square root of 2100, which I'm quite sure we can simplify that root. Well, 100 is a perfect square, so if we divide by 100, we would have the square root of 100 times the square root of 21. So it's a terrible marker. Okay, so our b would equal 10 times the square root of 21. Okay, so now we need to find an approximated value of 10 times the square root of 21. So if you type that in your calculator, you type in 10 times the square root of 21, you get approximately 45.8 feet. Okay, so if we say 75 minus 45.8, we get 29.2. All right. So if this is 45.8, then this is 29.2. And that gives us our full 75 feet. So we figured out what this height is here. So now the next question says, is the supporting wire at regulation height? So is 3/5 of 75 at least 45.8? So just multiply it. 3/5 times 45, or I mean 3/5 times 75, and you will get 45 feet. So since this is bigger than 45 feet, then yes, it is in regulation. It's 45.8. So it's 0.8 more than regulation requirements. So that's it. All right, press pause and try practice 7, please. All right, for practice 7, you should have got the square root of 193, which is approximately 13.89 inches. Okay, that's it. Check Google Classroom for the assignment. There will be a few questions here on Pythagorean theorem, and most of them will come from chapter 11 though.